Welcome to All Force e-learning. So yesterday we have completed the physical properties of halogen compounds. Now we will start chemical properties in session 6. Chemical properties of halogen compounds. Chemical properties of halogen compounds here. Then how can you explain the chemical properties of halogen compounds? Means based on the halogen structures we can explain chemical properties of halogen compounds here. Halogen compounds are chemically active compounds. Halogen compounds are chemically active compounds. They do not available in free state. Majority of the halogen compounds are synthetic halogen compounds. Majority of the synthetic halogen compound means most of the halogen compounds are used in the preparation of other organic compounds. That means chemically very important compounds, we will say that one here. So now how can we explain the chemical properties of halogen compound? Means based on the bonding nature we can explain chemical properties here. So here based on the CX structure means carbon halogen bonding nature. Based on the carbon halogen bonding nature we can explain properties of halogen compounds. So the carbon is having sp3 carbon or sp2 carbon, doesn't matter. Based on the number of sigma bonds we can explain hybridization state of given carbon. But here carbon and halogen, X is equal to halogens. Halogens are highly active compounds and more electronegative elements. That means when compared to halogens, carbon electronegativity is less. That means in between the two heteroatom electronegativity difference is there. So according to that concept, the bond undergoes heterolytic cleavage but not homolytic cleavage. Not equal distribution of electrons in between the carbon and halogen. Unequal distribution of electrons are possible whenever the bond undergoes cleavage in between the carbon and X. Due to the presence of more electronegativity of halogens are having partial negative charge, less electronegativity. Carbon electronegativity is less when compared to halogens. According to that concept, the carbon is having partial positive charge. Based on this concept, the bond is polar bond. Here. So due to that reason, these molecules undergoes substitution reactions. Substitution reactions means there are three types here: free radical substitution reactions, electrophilic substitution reactions, nucleophilic substitution reactions. Now substitution means whatever reaction is given, in that reactions one atom or one ion is substituted by other one is called substitution reactions. Whatever halogen compound is given, the halogen compounds undergoes nucleophilic substitution reactions. That means the X minus is substituted by incoming minus group, incoming minus ion. Whatever nucleophile is given, doesn't matter. So based on the given structure, in that structure one nucleophile is substituted by incoming nucleophile is called nucleophilic substitution reactions. That means if you write the halogens order, reactivity order, iodide reactivity is greater than bromide, bromide reactivity is greater than chloride, like this here. Wherever alkyl group is given, tertiary alkyl halide reactivity is greater than secondary alkyl halide is greater than primary alkyl halide group here. So tertiary alkyl halides reactivity is greater than secondary is greater than primary halogen compounds here. Only primary halogens is given. How can you explain the reactivity of primary connectivity halogens? For example, here methyl X is given, methyl X, here ethyl X is given, ethyl X, here propyl X is given, propyl X is given, propyl chloride, propyl bromide, propyl iodide with the same halogens. With same halogens, number of carbons increases, then reactivity decreases. That means whenever non-polar chain length increases, halogens nucleophilic substitution reactivity decreases here. Which is having more reactivity according to that concept? Here methyl halide reactivity is more when compared to ethyl, ethyl is more when compared to propyl, propyl is more when compared to butyl. This is the way to explain the monohalogens nucleophilic substitution reactions here. So nucleophilic substitution reaction means what here? In which reactions one nucleophile is substituted by another nucleophile is called nucleophilic substitution reactions. Totally, nucleophilic substitution reactions are divided into 3 classes. Nucleophilic substitution reactions, how many types here? 3 types. One is unimolecular nucleophilic substitution reaction. Unimolecular nucleophilic substitution reaction. Unimolecular nucleophilic substitution reaction means SN1. Unimolecular nucleophilic substitution reactions. SN1. 1 means uni, N means nucleophile, S means substitution. Unimolecular nucleophilic substitution reactions. 1 means what? Uni, N means substitution. S means substitution, N means nucleophile. Unimolecular nucleophilic substitution reactions, SN1 reactions. Bimolecular nucleophilic substitution reactions. Bimolecular nucleophilic substitution reactions. Bimolecular nucleophilic substitution reactions, SN2. 2 means bi, N means nucleophile, S means substitution. Bimolecular nucleophilic substitution reactions. Third one is intramolecular nucleophilic substitution reactions. Intramolecular nucleophilic substitution reactions. Intramolecular nucleophilic substitution reaction, here SNI. Intramolecular nucleophilic substitution reactions are internal nucleophilic substitution reactions. I means intra, N means nucleophile, S means substitution. So 3 types: unimolecular, SN1 reactions, SN2 reactions, SNI reactions here. SNI reactions. Now we will see SN1 reactions. SN1, unimolecular nucleophilic substitution reaction, example and mechanism. Unimolecular nucleophilic substitution reaction means what type of molecules undergoes unimolecular nucleophilic substitution reactions? Majority of the tertiary alkyl halides undergoes unimolecular nucleophilic substitution reactions. Unimolecular nucleophilic substitution reactions. The reactivity order of halogens. The reactivity order of halogens. Tertiary alkyl halides. Tertiary alkyl halides is greater than secondary alkyl halides is greater than primary alkyl halides is greater than CH3X. So in SN1 reactions, the reactivity order is tertiary is greater than secondary is greater than primary is greater than methyl halogen compounds. Halogen compounds. For example, here carbon is given, which is having three different alkyl groups R, R1, R2. Here X. R1, R2, X. So according to connectivity order, given substrate is carrying chiral center. Chiral center X, R group, different R group, again different R group. Maybe ethyl, propyl, butyl, like this. So tertiary alkyl halide is given. Tertiary alkyl halide reacts with reagents which is carrying nucleophiles. Reacts with reagent which is carrying nucleophile. Nu minus nucleophile. X minus is substituted by Nu minus. X minus nucleophile is substituted by which one? Nucleophile. So here carbon is given R group, again R1, again R2, here Nu, plus again Nu nucleophile, R group, again R1, R2, R2 here. Due to the presence of chiral center, the molecules follow the racemic mixture. Racemic mixture here. If reactant is carrying chiral center, then form the racemic mixture. 50% D form, 50% L form, or 50% positive form, or 50% negative form, or one is having R configuration, other one is having S configuration, or maybe first one having S configuration, second one having R configuration. So both are having different configuration, means the mixture is generally called racemic mixture. The non-super impossible mirror image relationship is called racemic mixture. So if reactant having chiral center, then form the racemic mixture. What is the position of outgoing group here? Right side is given. What is the position of incoming group in first compound? Right side. Both are having same side position, means compound is generally called retention compound. Retention compound. Exactly, incoming group position is opposite of outgoing group. The compound is generally called what? Inversion. Inversion. Inversion, retention. So retention product, inversion product, both are possible here. But you remember always, in SN1 reactions, whenever racemic mixture is formed, always inversion percentage is somewhat more when compared to retention percentage. Based on the mechanism, we can explain that concept. How can you explain? The compound is having majority, means based on the mechanism we can explain that concept here. Finally, X minus nucleophile is outgoing group, Nu minus nucleophile is incoming group, leaving group and entering group here, entering group. Based on the mechanism we can explain that concept. So unimolecular nucleophilic substitution reactions mechanism here. How to write the mechanism? Given substrate is having three different alkyl group and X. Here carbon is given. Here R group, R1, R2, again X. R1, R2, again X. First step. This one is first step. First step is slow step. First step is slow step. Whatever reaction is given, slow step is generally called what? rate determining step. How can you determine the rate? Means based on the slow step and fast step. So slow step is rate determining step. Rate determining step here, RDS step. So first step slow step and rate determining step. First step is bond cleavage step. Then how to cleave the bond means based on the bond nature we can explain. Due to the presence of more electronegativity, the bond electron migrate towards X minus. The bond electron migrate towards X. X act as a what? X minus nucleophile, outgoing nucleophile here. So bond undergoes heterolytic cleavage. The X released as X minus here. X minus, Cl minus, Br minus, I minus, like this. Because we are going to discuss about halogens. That's why we have to take chlorine or bromine or iodine in this case. Now X minus means which is going to lose the electrons? Carbon. Now carbon is having what type of charge? Positive charge. Positive charge. Then carbocation is formed in this case. Carbocation. Here R group, again R2, again R1, R2. So having what type of charge here? Positive charge. What type of charge here? Positive charge here. Positive charge. Intermediate is carbocation intermediate. Carbocation intermediate. Intermediate is carbocation intermediate. You remember in organic reactions, whatever reaction is given, if the reaction proceed via carbocation intermediate, then rearrangement is possible. Carbocation means the carbon is having positive charge. Then how many bonds are less here? One bond. Nothing but remaining 3 bonds are there. sp2 hybridized carbon is formed here. sp2 hybridization. sp2 hybridization carbon is. So already I told you, having sp2 hybridization. If intermediate is carbocation intermediate means, if intermediate having C plus, nothing but carbocation intermediate is formed means rearrangement is possible. Rearrangement is possible. That means in SN1 reactions, based on this substrate, we can write the final product. Rearrangement is possibility means we have to give priority order to that one only. So rearrangement is possible here. Rearrangement is possible here. Rearrangement is possible. Again, second step is nucleophile attacking step. Second step. This one is second step. Second step. First step. First step. Again, nucleophile attacking step here. Nu minus. Nucleophile attacking step. Entering nucleophile, Nu minus means entering nucleophile, X minus means outgoing nucleophile here. So nucleophile attacking step. The nucleophile attack that C plus, front side or back side doesn't matter here. Both sides will possible in this case. So front side is possible and back side also possible here. Whenever nucleophile attack that exactly opposite of leaving group means will get retention product, inversion product. Exactly opposite position means will get retention product here. Retention product. Exactly incoming nucleophile occupy that position of X means retention, opposite position means inversion here. So two possibilities are there here. Two possibilities. So here final compound means here C R group, again R1, again R2, here Nu. Opposite position is given. Nucleophile, here R group, R1, R2. So retention product, again inversion product. Retention, inversion product here. Retention, inversion product. The mixture is generally called racemic mixture. Racemic mixture. Non-super impossible mirror image relationship is generally called what? Racemic mixture. Nothing but in unimolecular nucleophilic substitution reactions, the substrate is carrying chiral center form the racemic mixture. If there is no chiral center, form the only one product. Form the only one product here. This is the way racemic mixture is possible or not. We can explain. How can you explain means what? Based on the substrate connectivity. Based on the substrate carbon connectivity, chiral center is there means form the racemic mixture. No chiral center means single product is possible here. Single product is possible in this case. Right, this is the way to write the mechanism. That means unimolecular nucleophilic substitution reactions, first step is bond cleavage step. First step is bond cleavage step. So that means rate is directly proportional to first step, nothing but slow step. Slow step. Which one is slow step? First one or second one? So according to mechanism, first step is slow step. First step is slow step. In first step, how many components are involved in this case? Only substrate, only reactant. Only reactant. That means unimolecular nucleophilic substitution reactions rate mainly depends on concentration of alkyl halide only. Alkyl halide. So here rate is directly proportional to alkyl halide only. Alkyl halide, but not depends on incoming nucleophile. Unimolecular nucleophilic substitution reactions rate depends on only given substrate or given reactant. So rate is directly proportional to Rx only. So molecularity is equal to, according to kinetical theory, first order reactions. First order reactions. Molecularity is equal to 1. Molecularity is equal to 1. 1 means unimolecular nucleophilic substitution reactions. 1 means unimolecular nucleophilic substitution reactions here. So if you check the reactivity order of unimolecular nucleophilic substitution reactions, tertiary alkyl halides are having more reactivity when compared to secondary. Secondary is more when compared to primary. Primary is more when compared to methyl halogen compounds. So in unimolecular nucleophilic substitution reactions, rearrangement is possible due to the presence of carbocation intermediate here. What type of medium is suitable for unimolecular nucleophilic substitution reactions? Polar protic solvents are favorable for unimolecular nucleophilic substitution reactions. Unimolecular nucleophilic substitution reactions. Polar protic solvents are favorable in this case. Rearrangement is possible here. Rearrangement is possible here. So if you check that one example for this one. For example here CSC is given, here C2H5 is given, C2H5 is given, here H is given, here Cl is given. H is given, Cl is given, C3H7 is given. Given substrate is carrying how many chiral carbons? One chiral carbon here. The compound reacts with NaOH. NaOH, remember aqueous NaOH is given, the molecule undergoes nucleophilic substitution reactions. Alkalic medium is given, you remember always, alkalic medium is given, elimination takes place. So aqueous medium is given, removal of nothing but molecule undergoes nucleophilic substitution reaction. Cl is replaced by, or Cl is substituted by incoming nucleophile. Which one in this case? OH. Due to the presence of chiral center, form the racemic mixture. Here. 50% D form, 50% L form. 50% D form, 50% L form. Racemic mixture is formed. Racemic mixture is formed in this case. How to write the mechanism means already we have done that one. Based on that concept we can write a mechanism for this one. This is a way to explain the SN1 reactions. SN1 reactions. So we will see next one, SN2 reactions. 2 means what? Bimolecular. N means nucleophile. S means substitution. Bimolecular nucleophilic substitution reactions. Bimolecular nucleophilic substitution reactions. Bimolecular nucleophilic substitution reactions is given. How to write the reactivity means, here normal alkyl halides are having greater reactivity when compared to primary. Primary is more when compared to secondary. Secondary is more when compared to tertiary. This is the way to write that reactivity order of bimolecular nucleophilic substitution reactions. For example, here substrate is given, substrate or reactant is given CH3, here H is given, here D is given, here X is given, here X is given. Given substrate is primary or secondary or tertiary. How can you identify this one? Based on the connectivity of carbons. The halogen connected carbon is connected with what? Only carbon. That means only one CC bond. Only one CC bond. The primary carbon is having X means primary halogen compound. Given substrate is primary halogen compound. Primary alkyl halide compound undergoes nucleophilic substitution reactions. The X minus is substituted by incoming nucleophile. X minus is substituted by what here? Incoming nucleophile. Here CS3 is given. Here CS3 is given. Again H, again deuterium D is given. D is given. So primary compound. Incoming group position is exactly opposite of leaving group. The product is generally called what? Walden inversion product. Walden inversion product here. Walden inversion product. You remember always, if substrate is having chiral center, form the Walden inversion product in bimolecular nucleophilic substitution reactions. In bimolecular nucleophilic substitution reactions. If reactant is not carrying any type of chiral center, then form the simple product, but configuration is exactly opposite. Which configuration? Incoming group, incoming nucleophile occupy that position of exactly opposite of leaving group. Inversion product is formed, but that one is not called as Walden inversion product. Chiral center is there, then we will say that one is Walden inversion product here. Then how can you explain that one means? Based on the mechanism we can explain. Mechanism of bimolecular nucleophilic substitution reactions. Here given compound having methyl group, deuterium, hydrogen X. Here H is given, D is given, here methyl group, here X. Here first step is slow step. First step, again slow step. Already I told you which is useful to determine the rate. Slow step only. Slow step, rate determining step here. Rate determining step. Again nucleophile attacking step. Nucleophile attacking step. The nucleophile attack that substrate exactly opposite of leaving group. Exactly opposite of leaving group here. Leaving group. Supposed to be 10% bond cleavage is possible in between the carbon and X means 10% bond formation is possible in between the carbon and incoming nucleophile. 50% bond formation is possible in between the carbon and incoming nucleophile means 50% bond cleavage is possible in between the carbon and outgoing nucleophile. 50% bond cleavage 50% bond formation. The state is generally called transition state. So here X, 50% bond formation in between incoming nucleophile and carbon, 50% bond cleavage in between outgoing nucleophile and carbon. Here hydrogen, here methyl group, again deuterium compound. The state is generally called transition state. Transition state. You remember, unimolecular nucleophilic substitution reactions proceed via carbocation intermediate. Bimolecular nucleophilic substitution reactions proceed via transition state. Transition state here. Transition state. Less stable intermediate. Less stable intermediate. Again, second step is first step. Second step is first step here. First step. Second step, first step. And bond cleavage step. Bond cleavage step. X released as X minus. X released as X minus. X released as X minus here. X minus. X minus, then form the Walden inversion product. Then form the Walden inversion product here. Walden inversion product. Then now order. Rate is directly proportional to what? Slow step. Which one? First step. So rate is directly proportional to slow step here. Rate is directly proportional to slow step. That one is rate determining step here. Rate is directly proportional to means the rate mainly depends on concentration of substrate and incoming nucleophile. In bimolecular nucleophilic reactions, the rate is mainly depends on two compounds. One is substrate, one is incoming nucleophile. One is reactant, one is incoming nucleophile. So rate is directly proportional to alkyl, halide and incoming nucleophile. Incoming nucleophile. That means in this reaction, rate depends on two components. Due to that reason is called what? Bimolecular reaction. Bimolecular reaction. Molecularity is equal to 2. Kinetical order means 2 here. Bimolecular nucleophilic substitution reactions. SN2 reaction. SN2 reaction. Bimolecular nucleophilic substitution reaction. SN2 reaction in this case. So you remember, reactivity order means here primary, secondary, tertiary. Here single step reaction, concerted mechanism is possible here. Wherever SN1 reaction is given, non-concerted reaction, multiple steps are possible here. The reaction proceed via less stable intermediate transition state. That SN1 reaction proceed via carbocation intermediate. Carbocation intermediate. This is the way to explain the given reaction is SN1 or SN2 reactions. SN2 reactions. Thank you.